Assalamualaikum and hi. This experiment will demonstrate the use of atomic absorption spectroscopy as a tool to determine the concentration of iron and cadmium in mustard leaf, where the data of this instrument will be quantified by standard addition method, and this video was prepared by our team. In EAS analysis, which is atomic absorption spectroscopy analysis, the instrument does not directly measure concentration. The output obtained from this instrument is in absorbance value. To establish the relationship between absorbance and concentration, a calibration curve needs to be constructed. The absorbance value measured will then be used to determine their concentration in mustard leaf quantitatively. For your information, calibration curve can be conducted in various ways. For this experiment, standard addition method was selected because it can minimize matrix interference from the sample. It can also help to improve accuracy of the analysis. For this experiment, there are two steps involved for the quantification of iron and cadmium using FAAS. First are the digestion of mustard leaf to extract the metal iron from sample. Next, a standard addition solution for iron and cadmium were prepared to construct the standard addition calibration curve. This is the standard addition method of iron and cadmium preparation. This is the instrument of a flame atomic absorption spectrometer, which is the machine name is atomic absorption spectrometer. The brand is A-Analyst 400 per kin Elmer. So the radiation source is the line source, and the detector is photomultiplier tube, which is PMT. So here is the instrument setup. So this is the lamp compartment, while this is the burner, and this is the nebulizer. To run the instrument, we click on the lamp button, then select the lamp that corresponds to the desired element, then click on method, then click new method, then click choose desired element. For this setting, we choose iron, then we click OK. Then we define the method description, which is determination of iron. Then for the read parameter, we set like this, and then for this experiment, we choose a equation of the nonlinear through 0. We go to the standard concentration, then fill in the sample ID and the concentration for each sample accordingly. Then we save as, then we click method. Then we write the name of this method. So the lamp energy is now set. Then click on manual button. Click open. Click on result button to see the result. Click on the flame button and click on to turn on the flame. So here's the flame light on. And now insert the nebulizer into the first sample flask. When the flame turns orange, click on Analyze Standard. Remove the nebulizer when the result has been recorded 3 times. Wait until the flame turns blue before proceeding to the next sample. Then for sample 2, and then we repeat the same step for other sample and also the other element, which is cadmium. So here's is the data outcome. So this is the calibration curve for standard addition method. The real concentration X can be determined by using Y equals to 0 in the calibration curve equation. From the iron graph, it shows that Y equals to 0.0673, X plus 0.1984. When Y equals to 0, it shows that X equal to 2.948 mg over liter. Since the sample is diluted, the actual concentration of the analyte was determined by multiplying the concentration obtained from the calibration curve with dilution factor. For example, dilution factor is 50 over 10 and the answer is 5. The actual concentration is X times 2 dilution factor, which is the answer is 14.74 mg over L. Okay, so this is the calibration curve for cadmium. So we just do the same, which is we get the actual concentration is 4.485 mg over liter. So this is the data and result for iron. We can see it stated that mean, standard deviation, and percent of RSD. So the mean is 0.262, and the percent of RSD, which is relative standard deviation, is 0.16. Next, this is the data for the cadmium. So from data obtained, the mean absorbance and percent of RSD for each sample were recorded and evaluated. So that's all from us. Thank you.